Let me record the session. My today's topic is problem discussion. On the topics of probability distribution and expectation and variance. Okay. So here goes your first problem. The question is as follows. Let me write the question. This question has a specific name. It is called random walk problem. A very interesting problem. In mathematical community, this problem is actually known as drunkard's problem. Anyways, the problem goes like this. Starting from the origin, unit steps are taken. To the right with probability P, and to the left with probability Q. Probability Q, which is equal to 1 minus T. As you all know, assuming independent steps, find the mean and variance of the distance moved from origin after small n steps. So this is, first of all, is not a physics problem, and this particular problem is actually a drunkard's problem. As you can see from the structure of the problem, that drunkards actually give this kind of steps. Okay, that their steps are not calculated. Sometimes they're moving to the right, sometimes they're moving to the left. And so since this is not a physics problem, so you shall not be able to apply the speed distance formula to calculate the distance after n steps. So this particular problem has to be dealt not from the physics point of view, but from the statistics point of view. First requirement. So suppose this kind of problem is given to you. First requirement is to define a random variable. So step number 1, you have to define a random variable which will justify the conditions given in this particular problem. So we shall associate. Let us associate a random variable xi. Okay, which is the ith step, which corresponds to the ith step, and this means that actually it means that distance covered after ith step. Okay, in this manner I am defining the random variable. Defining random variable is a very important part of the problem. Now, how to define the random variable? We have to give a mathematical picture to this. So we are writing it in the following manner, because the movement is sometimes to the right and sometimes to the left. So how can we justify this movement mathematically? So what we can do is that we can give a name to this particular random, we can put a value to this particular random variable, which we denote by +1. It's a mathematical value, and it means that this value is attained if the ith step taken is towards right. Okay, so this is my definition by which we are defining the random variable xi, and correspondingly we can consider -1 to be another random variable, another value for the random variable, and it corresponds to the system when the ith step taken is towards left. Okay, so this is how we can define the random variable. Now what we are interested in is to find the distance moved from origin after the n steps. So this is very important part. Okay, so this particular statement which is given in the problem tells me that we have to construct a random variable, another random variable, capital S, which is nothing but the sum of the random variables which have been defined in, say, equation number 1. Okay, so this S is nothing but the sum of the random variables x1 plus x2 plus dot 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 plus xn. Okay, x1 is the first step. This can take the value +1 or -1. X2 is the second step. This can be this can take the value +1 or -1. Xn is the nth step. This can take the value +1 or -1. We will never know because it is the drunkard's problem. In short, we can consider to be the, we can write it as summation I over xi. What is this? By this random variable, we actually mean this represents the random distance, the random variable measuring the distance moved from origin after n steps, after small n number of steps. Okay, so a capital S is actually the sum of several random variables. Just look at the definition of capital S. It is the sum of several random variables defined in equation number 1. What do we want to find? Actually, we are supposed to find the mean and variance of this random variable capital S. We are interested in finding the mean and variance of this random variable capital S. But before that, we have to find out the mean of this random variable xi and variance of this random variable xi, and then we'll think of how can we find the mean of capital S and variance of capital S. So my step number 2 is this. Let us calculate expectation of xi. The mean of ith random variable corresponding to the ith step. So what is the formula for this? Now you see that according to the condition given in the problem, if xi is having these two values, steps towards right and step towards left, then it is given in the problem that the probability corresponding to the right side step is equal to small p, and probability corresponding to the left side step is equal to small q, which is equal to 1 minus 2. By now you already know that this can be done. The expectation formula, as you can recall, is given by this. Expectation of x is equal to summation over x into probability of x equal to small x for discrete random variable. And obviously this variable is discrete because it has only two values, +1 and -1. So we can apply this for particular formula, and by the rule we can write it as 1 into small p plus -1 into 1 minus small p. or you can write q, whatever. So if it is, or you can write 1 into p plus minus 1 into q, and you see that this is nothing but p minus q is the mean of the random variable xi, and it is true for all I, because every random variable has been defined in the following manner. Okay, I'm going to the next page. Now in step number 2, we need to calculate the variance of xi. We know that for any random variable, variance of x, which we actually denote by vx sometimes, it is given by the formula, as I discussed in the previous class. It is given by the formula e of x square is equal to minus e of x whole square. Now, according to this particular structure of the formula, we can write variance of xi to be expectation of xi square minus expectation of xi whole square. What do we need to find right now? We need to find the expectation of xi square. Again, let us consider the chart. We have these values for xi, which are +1 and -1, and the probabilities are small p and small q. And we know from our previous class that expectation of x to the power n, when n is positive number, it is given by summation x to the power n probability of x equal to small x over all x. So by this rule, expectation of x I squared, this quantity will be +1 whole square into p plus -1 whole square into q, which is equal to p plus q, isn't it? It is p plus q, and this is true for all I. This is true for all I. Now, as we have found the expectation of xi square, we can substitute this value in the formula of variance. So we are putting here p plus q. We are putting here p plus q, and minus expectation of xi came out to be p minus q. And since a square term is there, we can write it as p minus q whole square. No problem with this. But if you want to do a little bit of manipulation to the given result, because this result is actually very clumsy. So if we want to do a little bit of manipulation, in the next step, what we can do is that we can write it as p plus q whole square minus p minus q whole square. Why is it so? Because ultimately we are dealing with probability, and p plus q is equal to 1. Therefore, p plus q whole square is actually not changing its value. It is also 1. Okay, so we can write p plus q as p plus q whole square. Okay, every time it doesn't happen, it is happening for this particular problem. Okay, and why have I done so? Because we know there is a formula which goes like this, that a plus b whole square minus a minus b whole square. If we expand and we calculate the thing, it is coming as 4ab. Okay, so little bit of algebra we are doing over here, and that is 4p. Now the result is actually not clumsy. If someone stops over here, if someone says that we will do up to this, it's okay, no problem. Mathematically, he's right. But if you want to remove the clumsiness, you can do a little bit of algebraic manipulation to the given system. So in step number 2, we have got our expectation of xi and variance of xi, and is true for all I. So for individual random variables, the expectation and variance have been obtained. My step number 3 is to calculate the expectation of capital S, which is the sum of all the random variables. So it is actually expectation of x1 plus x2 plus dot 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 plus xn. Okay, and now at this point you need a particular theorem. Whenever I will send you the note, one note has already been sent you through Google Classroom. Another note will be sent very soon. And if I send you the note, you will see that there I have mentioned certain properties of expectation. I am not mentioning these properties in the classroom because it will just kill the time. Whenever you will get the note, you will get to see the properties. The proof of the properties are not required at all. We have to remember these properties. One of the properties is very simple. It is saying that if capital X and capital Y are any two random variables, expectation of X plus Y is equal to expectation of X plus expectation of Y. One of the property is this. So if I apply this particular formula to our current problem, we will be getting the following thing. We can write it as expectation of x1 plus expectation of x2 plus dot 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 plus expectation of xn. And since each of the expectations are p minus q, so we have p minus q plus p minus q plus dot 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 plus p minus q. How many p minus q are there? N p minus q are there. So we have got n times p minus q has been added to itself. So the ultimately we are getting the result to be n into p minus q. So this is the expectation of this particular random variable that we defined in our previous page. Now let's come to the point of variance of S. We want to calculate the variance of S, which is equal to variance of x1 plus x2 plus dot 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 plus xn. Now here goes a very important theorem which is related to variance that you have to note down. The theorem is that if capital X and capital Y are independent random variables, okay, then variance of x plus y is equal to variance of x plus variance of y. Remember, variance of x minus y will also be variance of x plus variance of y. Okay, and here expectation of x plus y is expectation of x plus expectation of y. Expectation of minus y will also be expectation of x minus expectation of y. But here is something different. For both of variance of x plus y and variance of x minus y, the result is vx plus vy if the xy's are independent. Otherwise not. Otherwise some extra term will be there. This extra term is actually missing from expectation. So the two formula are actually different. Here capital X and capital Y are any variable, are any random variable, not necessarily independent. Okay, remember this. And here we have considered the independent variable. But this particular formula for variance is actually be applicable to our given system, because in the given problem, it is already mentioned that the steps taken by the drunkard is a independent step. So in our problem, the steps xi for all I are independent. It is mentioned in the problem. And so variance of S will become variance of x1 plus variance of x2 plus variance of xn. Now each of these variances are how much? We have already calculated. They are 4pq plus 4pq plus 4pq. And how many 4pqs are there? N 4pqs are there. So we will write it as 4n pq or n into 4 times n times 4p, whatever. So this is the solution of the given problem, that by the help of this, by defining the random variable in a proper way, proper justified way, and calculating the expectation, we can easily calculate the random variable. We can easily calculate the expectation and mean of the random variables. Now, this is one of the problems that I wanted to discuss with you. Let's go to the next problem. I hope that you have taken the screenshot of the problems, or later it is as the session is being recorded, so you will be getting the video in the YouTube, no problem. Anyways, let's go to the next problem. The next problem is as follows. In the previous class, I told you that the formula of a binomial, the mean of the binomial random variable, and the uh, variance of the binomial variable. So we know that if Ex equal to NP and Vx equal to NPQ, if the random variables X is a binomial variate, it's a binomial variate. Okay. Very interestingly, you see that in the above problem that we have done explicitly by defining the random variables, you see, carefully observe that this random variable xi that I have defined over here is actually a binomial random variable, because it has some values, and for individual values we have two probabilities. If I consider ith step to the right to be the success, then my probability of success is small p. If I say that the ith step taken to the left is the success, then small q is my probability. And how many times we have taken the steps? N times we have taken the steps. So n is the number of experiment. So obviously we'll be able to apply the binomial formula to the given problem. Okay, try to do the problem using the binomial distribution formula. Okay, and try to see whether the same result comes out or not. So first of all, let me say that homework. Try to solve above problem considering xi to be a binomial random variate, to be a binomial variate. Okay. Okay, so I was telling that this was the thing that I discussed in the previous class. So this particular information that you have obtained about the mean and variance of the random variable, binomial random variable, it is very powerful application in practical field. Suppose someone claims that, okay, let me put the problem in the following manner. Let us try to comment on the following system. Okay, what is your comment? The mean in a certain experiment, the mean of a binomial distribution or variate has come out to be 3, and the variance of the binomial variate has come out to be of a binomial variate has come out to be 4. So the supervisor has asked us to put some light on this particular information. Suppose you are actually conducting a statistical experiment and you have sent your subordinates to the system to collect information, and you have asked him how the system is behaving and give his outcomes on the experiment that he has performed. Now the subordinate comes to you and he says that he thinks that the system is behaving binomially, and therefore he has calculated that the mean of the binomial variate is 3 and variance of the binomial variate is 4. Now you see the powerfulness of the above information, the powerfulness of this information. Immediately he declares this, we can verify his comment. How? If he says that his random variable is binomial, okay, and we know that for binomial random variable, the expectation of x is equal to np. So he is claiming that his mean is 3. So his np is 3. Also, he is claiming that the variance of the random variable x is 4. So actually, he is claiming that np cube is 4. Immediately after this, we see that if I divide the variance by the expectation to calculate the probability of successes, what we get npq by np, and this is actually q, and that is nothing but equals to 4 by 3. But 4 by 3 is greater than or 1. It cannot be, it is very absurd, because q is a probability and it has to be, it should lie between 0 and 1. That means from this particular short calculation, your deductions will be either your subordinate is lying, he has not performed any operations, he is just uh, giving his inputs or his outputs just like that, okay, from nowhere. Either he is lying or he has done something wrong in guessing the system, something wrong in guessing the system. Okay, so without looking into the values of the random variables, the definition of the random variable, without getting into the details calculation of expectation and variance, simply by using this powerful formula, we can say that okay, this particular comment is actually a mistake. It cannot be. The binomial variable cannot behave like this. Okay. So this is a very important, interesting example that I wanted to discuss with you. Let's go to the next problem, which is as follows. In a binomial distribution, consisting of uh, consisting of 5 independent trials, 5 independent trials. Okay, probabilities of 1 or 2 successes, are 0.4096 and 0.2048 respectively. Okay, and the question is, find the parameter small p, of the distribution. Now the question setter has already declared that you have to treat this particular situation as a binomial distribution. Okay, it is a declaration. This is a declaration. Somehow he is declaring this particular thing. If he declares that this system is behaving binomially, he needs to give me 2 parameters of the binomial distribution. And we know that the parameters of the binomial distributions are the number of experiments and the probability of success. Remember, when X follows binomial distribution, with parameters small n and p, okay, mathematically we write it as follows. Mathematically we write it as X is following binomial distribution with parameter n and this notation you keep in mind. Okay, it is actually, it saves our time. We don't have to write it in sentence. Now, as my X, the random variable X, whatever random variable is, we do not know what random variable the question setter is talking about, but whatever random variable, it is following a binomial distribution with parameter n and p, and it is known that parameter n is equal to 5 because 5 independent trials have been taken into consideration. Only thing we know that we do not know is the value of the parameter q. So it is the question is how to find the value of the parameter q. But it has been mentioned that probability of one or two successes is actually 0.4096 and 0.2048. I am asking all the participants to write their roll numbers in the chat box because time count has already been started. Chat box is activated now. Okay, we know for small x number of successes, for small x number of successes, the binomial probability law, probability of x equal to small x, is given by ncx p to the power x q to the power n minus x. Okay, but here my n is known, it is 5cx p to the power x q to the power n 5 minus x, and my p is also known. My no, my p is not known. That p I have to find out. Okay, with that we do not know the p. So this is the formula, and here the x is taking the value from 0, 1, 2, 3, 4, and 5. These are the values. Now, according to the condition given in the problem, according to the condition given in the problem, it is said that probability of one success is equal to 0.4096, and probability of two successes is equal to 0.2048. Now let us try to implement the formula as shown in the above paragraph. So it will be 5c1 p to the power 1 q to the power 5 minus 1, that is q to the power 4, which is equal to 0.4096, and that this one will be this will imply 5c2, okay, p to the power 2 q to the power 5 minus 2, that is 3, and that is 0.2048. Okay, so we have got two equations, one is this and another is this. So two equations, two unknowns. Okay, you can write it as 5c1 means 5, that is 5p q to the power 4, which is 0.4096, and 5c2 means 5 factorial by 2 factorial 3 factorial, that is 5 into 4 by 2, that is 10. So this is equal to 10 p square q cube, which is equal to 0.2048. Now what we are going to do, we are going to divide one equation by the other. Okay, so we can divide equation 1 by equation 2, or we can divide equation 2 by equation 1 as it is. Dividing equation 1 by equation 2, what do we get? 5p q to the power 4, 5p q to the power 4 divided by 10p square q cube, 10p square q cube, which is equal to 0.4096 by 0.2048. Now we are going to do a little bit of calculation over here. So we have half, and this is q, this is p, and that is 0.4096 by 0.2048. Let me find out how much it is coming. 4096 by 0.2048. So the result is coming as approximately, it is coming as 0.4096 by 0.204. It is coming as 2. We just check whether am I correct or not, and therefore we get q by p, which is equal to 4, and that means 4p is equal to q, but we know that q equals to 1 minus p, so we can resubstitute this, and this is 4p plus p, which is equal to 1, and that therefore it is 5p equals to 1, and p is coming out to be 1 by 5. Okay, and we are able to find, thus we are able to find the parameter, the other parameter of the binomial random variable, which is given in the following. Let me give you a problem which is you can test by yourself. The problem goes like this: an irregular six-faced die. By irregular means the die is not fair. An irregular six-faced die is thrown, and the probability that in 10 throws it will give 5 even numbers, 5 even numbers is twice the probability that it will give 4 even numbers. Okay, how many items in 10,000 sets of 10 throws, okay, each would you expect it to give no even number? Okay, so this is the problem that I'm asking you to solve. No, it is not numbered. I'm asking you to solve by yourself in your leisure time. So this is a kind of homework. Here you consider 10 to be your value of n. Remember, try to solve this particular problem, and since the time has already running out, so I'm